Okay, advanced math. I'm going to take the algebra to the next step here and talk about inequalities. Today we're going to stick to positive coefficients to get started. Make this the title of your next free page in your math notebook. Close it up and give me lots and lots and lots of concentration when you're done. So let me remind you of a couple things. First, let's talk about what inequalities are, because it's been a while. This is the sixth grade version of an inequality problem. Ryan has $20 to spend on school supplies for the year. He's already picked out a binder that costs $6.92. How much more money can Ryan spend? So this was an actual example from a previous mini lesson back in the sixth grade part of the year. So our variable here is how much more can he spend? And if I just read this quickly, I'd say, all right, well, I would solve this with saying $20 is his total amount of money, and he can spend $6.92 that he already spent, plus what he hasn't spent. That's going to add up to $20. There's an equation for my situation. $6.92 plus whatever's left makes 20, and I could solve for x easy. But we get in the habit so much of equations that we just write equal without thinking. And remember here, he does not have to spend $20. He can spend less than $20. So he can spend, we had a symbol, he can spend less than or equal to $20. He can spend less if he wants, that's just fine. So this situation is not actually an equation, it's an inequality. We'd say $20, not 20 degrees, has to be more than or equal to what he spent. Because it's fine as long as what he spends is less than $20. This side is less than $20. That's fine. If he spends $1, no problem. If he spends $2, no problem. As long as he's less than 20, he's okay. He doesn't have to spend exactly 20. And then remember, we used the exact same strategies we used before to find the variable. We said, okay, x has $6.92 being added to it, so the inverse operation is to subtract $6.92 from it. And that tells me that x can be anything less than or equal to what? Let's see, 20 minus 6 is 14, $13.08, I think. So as long as he spends less than or equal to $13.08, he's okay. So that's an inequality. It works just like an equation, but we're worried about the sign here, less than or equal to. So this tells me x can be anything less than or equal to 1308. All right. So here's this is an equation problem that we just did. So this is Nick opens a savings account in which he deposits $42.65. Each week after he deposits $25.80. In how many weeks will he have saved $500? So we have solved this exact thing as an equation up till now. We've said he's going to put in $42.65 and he's going to add to that $25.80 every week. And we wanted to know when that equals 500. And we've already done this problem lots of times. I want my calculator for this. So using the inverse operation strategy, I would subtract 25. Oh, no, I'm looking at it backwards. I'm sorry. I would subtract 42.65 from both sides, because he's already got that saved. And that would tell me 500 minus 42.65 is $457.35 to go. That's how much he's got to save, and he's going to do that at a rate of $25.80 per week. So if I divide now both sides by $25.80, then I get the number of weeks equals 17 and a little bit. So, but more than 17 weeks, less than 18 weeks. All right, so that we've solved that problem several times. So I want to think through the same problem, but let's think about it as an equality, right? inequality, because actually, when we think about saving, if we think about when will he have saved $500, it's okay if he has saved more than $500. So really the way I want to set this problem up is the exact same way, 4265 plus 2580 per week. And we've been saying this, but really we want to know when this will be more than, it's fine if this is more than $500 or equal to $500. That's what we really want to know. Because if he's got $600 or something, that's fine too. So when he has $500 is when he gets to that 17th week, plus any more time after that, he'll still have it and it'll be great. So I'm going to rewrite this as an inequality. Hard part is figuring out which way the sign goes. So make sure you think about that. So in this case, he can have more than or equal to $500. So sometimes you'll see words like this in there. When will he have saved at least $500? That lets you know like more is okay. That's an inequality word. And I solve this exactly the same way. If I go back and like even copy this over, the steps to solving an inequality are exactly the same as solving an equation. You just have a different sign. Like I don't have room for both, do I? Oh well. So just like in the equation, I'm going to subtract 4265 from both sides. And I'll get 2580 per week has to be more than or equal to 457.35. And then divide both sides by 2580. And I already know what that is because I just did it. And so I get the number of weeks has to be greater than or equal to 17 and a little bit. So this means it is fine if after 18 weeks he'll have enough money, after 19 weeks he'll have enough money, after 26 weeks he'll have enough money, after 512 weeks he'll have enough money. Anytime the number of weeks is greater than or equal to that, he'll have his money. So it's just like we've been doing, nothing new, same steps, just a different sign, nothing to be worried about. Okay? Let's do one together. Open your notebook up. And let's talk through this example that we did. This is another problem we've been solving as an equation, but really probably should have been an inequality. Right? We have that 100 milliliter beaker filled with 6 3/10 milliliters of water. Water is added to the beaker at a rate of 12.5 milliliters per minute. When will the beaker overflow? How many minutes will the beaker overflow? Because once it overflows, if you keep adding water, it's going to keep overflowing. So it's okay to say, well, really, it's not an exact number. It's anything past that number. So I want to know when the amount of water I started with plus the amount of water I add, 12.5 milliliters every minute. I want to know when that not only is equal to 100 milliliters, but if it's more than that, it's still going to be overflowing. It's fine if it's greater. Say still overflowing over 100. It doesn't overflow just at 100. And actually, you know what? I don't even know if that's right. Because at 100 exactly, it's probably not overflowing, right? At 100 exactly, it's full. So it's not even going to be greater than or equal to, I don't think. I think I really want to know when is it just greater than 100. Because it won't overflow at 100. It'll overflow over 100. So I'm going to change it to just a greater sign. I want to know when is the amount I add greater than what it can hold. That's overflowing. All right, and now my steps to solve are going to be just like they would be with an equation. I have plus 6 3/10, and I have times 12.5. So I'm going to do the inverse of those in reverse GEMS order. So the first thing I'm going to do is subtract 6 3/10 because that's already in there. So I may as well take that off my 100. And I'm going to get 12.5 per minute is greater than, let's see, 100 minus 6 is 94, minus another 3/10 would be 93 7/10. And then I have to divide both sides by 12.5. And I will get, let's see, 93 7/10 divided by 12.5 is about 7.5 minutes. When you get the number of minutes has to be more than 7 496 thousandths. That is when it will overflow. And so anytime greater than that, at exactly that number of minutes, it will be full. And when it's greater than that number of minutes, it will overflow. 8 minutes, 10 minutes, 100 minutes, still overflowing. So M can be anything greater than that. All right. So inequality is not that different from equations. You really just have to figure out what sign to put in there. That often is the hardest part, is figuring out less than, greater than, less than or equal to, greater than or equal to. But once you do that, you really just treat it like an equation and everything turns out the same. If that was tricky, please watch those again. I really, at this hard part of the year, need you coming to class every day super mega ready to go. So if you need to see these again, please do. And I can't wait to see you tomorrow. Over and out.